Welcome back, everybody. Let's continue to talk about displaying data. We've been focusing on frequency distribution tables and graphs. Of course, here's an example of a basic frequency distribution table. And we learned that we really like these tables because they summarize all of our data without losing any information. And what that means is all of the information about our data can be found in this table. And in fact, we could reproduce all the data. And in fact, we can compute other things based on the data using this table, so they're very flexible. But one thing you'll notice in all of our examples is that we've been dealing with a limited range of data. So for example, in this case, the only potential data points are the letter grades A, B, C, D, and F. Just imagine for a second if you take an exam, and that exam's out of 100 points. If we look at the data for an entire class, we're bound to have a wide range of scores. Some students are going to do really well, and some students are going to do a little bit more poorly. What that means is that in the end, we're bound to have a wide variety of scores. How can we deal with that huge variety of scores in a simple table? We're going to talk about that next. This is exactly the situation I was just describing. Imagine some exam scores. There are going to be some people who do really well, and some people who don't do quite as well. And we're probably going to be left with this large range of scores. And you can see one way that we can handle that is by grouping up those scores. So what we're going to do right now is talk about a grouped frequency distribution table and then also a grouped frequency distribution histogram. I'm going to show you how to create these groupings. We call these groupings classes or intervals. And we want to make them a particular way so that they're easy to read, so that they look nice, so that they're basically just consistent. And although these grouped tables are really nice, you can see it's really nice. We can see 3 students scored in the A range, 4 students scored in the B range. This is a very flexible and useful table. Even though they are very flexible, every time we make a decision, and in this case we made a decision to group our data, every time we make a decision, there are some benefits and some costs that go along with that decision. Let me show you what I mean. From a grouped frequency distribution table, can we reproduce the raw data? One thing we really liked about typical frequency distribution tables is that we lost no information about the data. And in fact, we could reproduce the data. But you can probably already see we're not going to be able to reproduce this data. I know that 3 students scored somewhere between 90 and 94, but I don't know what their actual scores were on the exam. So this table loses a little bit of flexibility, because from this table, I couldn't compute some other things then. So for example, oftentimes from a table, we just want to compute what the average score is, mu. So I have to ask myself, could I sum up all the data? Could I compute the sum of x? Well, if I don't know what the individual scores are, if I don't know what the x values are, I can't sum them up. And if I can't sum up all the x values, I can't compute the mean. That's okay. That doesn't mean that grouped frequency distribution tables should not be used. It just means that as data analysts, we need to decide what's the most appropriate strategy. And when we choose a strategy, can we deal with the trade-offs? This section right here provides a pretty good explanation of the trade-offs involved. Grouping our data really does allow us to efficiently summarize all of our data. That's a good thing. But we do lose specific information about that data in the process. That's okay. We can deal with that. All right, let's talk specifically about how to create one of these grouped frequency distribution tables. Specifically, how do we create those groups? As I mentioned to you before, those groups are known as classes or intervals. I typically call them intervals. We're going to deal with this data right here. There aren't a lot of data points in that data set, but there is a wide range of data points. As I look through it, the smallest value that I think I see is a 7. The highest value that I think I see is a 58. That's a pretty wide range of values. If we were to create a basic frequency distribution table and we had values ranging from 7 all the way up to 58, the table would be enormous. The table would be bigger than the data set. It simply wouldn't make sense to do it that way. So it really makes sense in this situation to group up this data. So we're going to do this together. I'm going to show you how that we can replicate all of this. But first, let's talk about these basic guidelines. If we understand the basic guidelines, then we'll understand how we can group together the data in a way that looks good and it's easy to read. First of all, when it comes to these intervals, we typically don't want to have more than 10 of them. In other words, we don't want to have more than 10 of these groupings. And that's because if we start having more than 10, the table really isn't summarizing the data very well. It's becoming too large. So this is just a rule of thumb, but in general, we want no more than 10 intervals. Here's another important one. We want to use intuitive intervals. What I mean by intuitive is pick some value that we count by very easily. We count by 5s very easily. We count by 10s very easily. 10, 20, 30, 40, 50. We don't count by 17s very easily. We don't count by 87s very easily. So when we group things up, we're going to group it up by a value that's intuitive. Here's another thing. Every interval, every grouping should begin with a multiple of the width. And this is what I mean by that. If we're going to be counting by 5s, every one of those groupings should start with a multiple of 5. If we're going to be counting by 10s, every single interval should start with a multiple of 10. You'll see exactly what I mean in a minute. Let's work on this together. Here's our data. It's not a very large data set, but there is a large variety of scores, ranging from a low of 7 to a high of 58. The first thing that I like to do is see how big is that range. In other words, what's the span from the lowest value to the highest value? So in this case, we're talking about a range that has a high value of 58 all the way down to a low value of 7, and that range would equal 51 data points. So in other words, I need to create some groupings around that range that spans 51 data points. Now I just use those guidelines to make a decision. Remember, there's not necessarily always one right answer. It's up to you as a data analyst to decide what's best. I know I want to create intervals, groupings, that are based on some intuitive value. So for example, I might start with 5, and I would say to myself, if I'm going to create groupings that have a width of 5 data points, then I'm going to probably end up with like 10 or 11 different groupings. Because remember, my range encompasses 51 data points. So that's a lot of groupings, and that already pushes the limit of one of my guidelines, because that first guideline says use no more than 10 equal intervals. So I just try to be flexible in my thinking. Then I say to myself, all right, maybe I'll create groupings that have a width of 10 data points. If my overall range is 51 data points, and I want to create groupings that have a width of 10, then I'm going to end up with like 5 or 6 different groupings, different intervals. And that sounds pretty good. So let's decide to use intervals that have a width of 10 data points. So I'll just jot that down. Width, W equals 10. Let's talk about where that first interval needs to start and end. According to our guidelines, we need to begin every interval with a multiple of the width. So let's talk about multiples of 10. You've got 0, 10, 20, 30, 40, 50. And we know we start these tables typically with the lowest values, and then as we move down the table, we have higher values. So let's think about the first interval that we need to include that smallest value, which is 7. So we're going to have to start with 0, which is a multiple of 10, and then move all the way out 10 spaces. Some people make a mistake, and for that first interval, they put 0 to 10. That seems like that could be right, but think about it logically for a minute. From 0 to 10 are actually 11 different digits. So that interval would not have a width of 10 digits. And think about what would happen next. The next interval would have to start with 11, and 11 is not a multiple of 10. So this first interval needs to start at 0 and end at 9. From 0 to 9, there are indeed 10 digits. The width of that interval is 10. And now you can see how everything falls into place really well, because the next interval is going to start with 10. And of course, 10 is a multiple of 10. This interval would start at 10 and go all the way to 19. The next interval would start with the next multiple of 10, which is 20. And that would go to 29. And then we would have 30 to 39, 40 to 49, 50 to 59. And because 58 is the largest value that we have, that's all we would need in terms of intervals. At this point, we can just put in the frequencies. If you look at those scores above, there are 2 people who score between 0 and 9, 3 people who score between 10 and 19, and then we have 8, 0, 4, and 3. Of course, we can include other columns for percentages, cumulative percentages, things like that. But right now, we're just keeping it simple so you can learn how to create these intervals. We'll get into that level of detail in just a minute. So that, my friends, is your first grouped frequency distribution table. Let's take a look at this prettier version for a second, and let's make sure our grouped table abides by the guidelines we just discussed. So the first guideline says use no more than 10 equal intervals. We do see that all of the intervals are equal. They all have a width of 10, and we have 2, 4, 6 of those intervals overall. So we have fewer than 10. That's good. We're supposed to use intuitive intervals. We used an interval of 10. That is intuitive. And we have to begin the intervals with multiples of the width. And we can see that each one of these intervals does begin with a multiple of 10, 0, 10, 20, 30, 40, 50. So it's kind of pleasing to the eye. It's consistent. It's easy to read. That's the way we want it to look. Next, let's recreate this table right here. It's based on the same data we've been dealing with, but it includes several other columns that are often very helpful. Most of the columns that you see here are columns that you're already familiar with. Cumulative percentage, percentage, cumulative frequency, frequency, real limits. What are apparent limits? The apparent limits are the limits of an interval as they appear. So they're known as apparent limits. They're simply the limits of the interval, like this interval right here, as they appear. So these right here are the apparent limits. Of course, we've learned that when we're dealing with continuous data, any given data point can actually be affected by its real limits. So in this table, we're going to show the intervals in terms of their apparent limits, and then we're also going to show the intervals based on their real limits. The midpoint will simply be the point right in the middle of that interval, and it's the point right there in the middle of each interval that we will use to plot the bars on a histogram. Let's start right here with the apparent limits because we've already worked on them. So I'm just going to reproduce them right here. We have 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49, and 50 to 59. And at this point, it's pretty easy to find the midpoints. The midpoint is just the point between the starting point and the ending point. And really, I think the easiest way to find it is just to average the starting point and the ending point of each interval. So the starting point of that first interval is 0, the ending point is 9. 0 and 9 equals 9, and 9 divided by 2 gives us a midpoint of 4.5. Let's look at that next interval. 10 and 19 equals 29, and 29 divided by 2 equals 14.5. That's the midpoint. The next interval, 20 and 29. If you add those together, you get 49. If you divide that by 2, you get 24.5. And you start to see a trend emerge. Once we found that first midpoint at 4.5, we can see every other midpoint is exactly 10 points down the number line. So this next one will be 34.5, the next one 44.5, and the last one 54.5. From above, we can see the frequencies. Let's just copy those down. There are 2 people in this interval, 3, 8, 0, 4, and 3. Let's talk about the real limits next. They are real limits, just like the real limits we talked about previously. And keep in mind that real limits always represent the midpoint between one value and its next closest value. Here we have a somewhat odd situation where the interval begins at 0, and the real limit to the left of 0 would be on the negative side of the number line. So technically, the lower real limit is negative 0.5. The upper real limit is based on the upper value of that interval. So what's the point between 9 and 10? That would be 9.5. So our real limits for that first interval extend from negative 0.5 all the way to 9.5. Let's look at the real limits for the next interval. That interval begins at 10. To the left of 10, halfway between 10 and 9, we would have 9.5. So that's the lower real limit for that interval. Let's talk about the upper real limit. the higher value in that interval is 19. So again, on that number line, I see 19, and to the right of it is 20. What comes right in between? 19.5. So the real limits for this interval would extend from 9.5 all the way to 19.5. For the next interval, we would have 19.5 extending all the way to 29.5. Then we would have 29.5 all the way to 39.5. 39.5 all the way to 49.5, and then 49.5 all the way to 59.5. All the other columns work exactly as they've worked before. Keep in mind that when we're looking at this first range of values, that first interval from 0 to 9, we had 2 values altogether. So the cumulative frequency at this point is 2. In order to figure out the percentage, we would need to know our n, so we can add up all of these values in the frequency column. 2 and 3 is 5, add 8, we have 13, add 7, we have 17, add 3, and we have 20. So we know that our n equals 20. If we have 2 scores that are between 0 and 9, then the percentage of scores would be 2 divided by 20, and 2 divided by 20 is 10%. And because this is the first row of our table, the cumulative percentage would be 10% at this point as well. Let's go through another row just so you remember how to do it. We have 3 people that scored somewhere between 10 and 19. So how many people scored 19 or less is essentially what we're asking for the cumulative frequency. 2 people scored between 0 and 9. We have 3 people who scored between 10 and 19, so we have 5 people who scored 19 or less. Let's compute that percentage. Don't forget, percentages are based on frequencies, cumulative percentages are based on cumulative frequencies. So I need to figure out the percentage of people who scored between 10 and 19. There are 3 people who scored between 10 and 19. 3 divided by 20. 3 divided by 20 equals 15%. So right here we can enter 15%. Let's talk about that cumulative percentage. Now we're trying to figure out what percentage of the people scored 19 or less. Remember, that's always based on that cumulative frequency. 5 people scored 19 or less out of 20. 5 divided by 20 equals 25%. So we can enter in 25% right here. And let's see if that makes sense using the simpler method that we've learned before. If we take 10% right here and add it to 15% right here, we do indeed get 25%. For practice, you should finish off this table right here on your own. And when you're done, your table should look like this. I reproduced the table right here, not only so that you can check your work, but also so that we can look at that table when we create a grouped frequency distribution histogram. Remember, for any histogram or any bar chart, we always have an x-axis right here, and then we always have a y-axis right here. The x-axis always represents our data values, in this case, the number line. And the y-axis right here always represents the frequencies. So on this number line right here, we're really representing these groupings. Each one of these bars represents one of those groupings, and we're going to center those bars right on the midpoint. So you can see for this first interval that ranges from 0 to 9, I've got it sitting right here at 4.5, extending from 0 all the way to 9. That next interval extends from 10 to 19. The midpoint is 14.5. So the next bar right here is sitting right in the middle at 14.5. And on that number line, it extends from 10 all the way to 19. The next bar has limits between 20 and 29. The midpoint is 24.5. So the bar is right there in the middle sitting at 24.5, and it extends from 20 all the way to 29. There was no one who scored between 30 and 39, so I guess one way to think about it is that there is a bar there, but that bar does not raise above a frequency of 0. And then you can see the other 2 bars, and I'm sure you understand how they were created. So that, my friends, is how we group our data and create a grouped frequency distribution table, and also a grouped histogram. In the next video, we'll talk about some alternative plotting methods. In the meantime, be safe.